In this video, I'm going to show you how to solve a multi-step equation in one variable using what's called a foldable. Now, a foldable is a math manipulative. In this case, I made this foldable to show all of the steps of solving an equation in one variable. Now, each of these represents a tab, and under these tabs are examples of what does the step mean. So for example, the first step is the distributive property. Now if I look at this, I have an example of what it means to use the distributive property, meaning I'm multiplying through in a sum. So what I'm going to do is show you how to use it to solve an equation. Now I plan on making a video of showing you how to make one of these, but that's later on down the road. So let's start with the equation. Now, the first thing I always have my students do whenever I solve an equation is draw a line through the equal sign. Now, I like to call it the brick wall. You might hear it called something else. But the reason I do this, there's twofold. First of all, it keeps their work organized, because a lot of times you'll see work start going diagonal and then it gets all messy and jumbled, and it's just bad news. But also, it helps them to see whatever I do on one side, I have to do on the other. So let's get into it. Now the first step says distributive property. Now looking at this problem, I know I'm going to have to use the distributive property twice. I see the parentheses, so I'm going to have to multiply. So I'm going to start with 5 times 2, so that's 10, and then 5 times negative x. Now in front of this x, it's what's called an understood 1. I like to say 1 is a ninja. You know it's there, but you can't see it. So I'm going to do 5 times negative 1, and that gives me negative 5x equals. Then I do the distributive property on the other side. So 3 times 2 gives me 6x. 3 times negative 3 is negative 9. And then this 3 just kind of stays where it is. So that's the end of the first step. There are no more distributions I need to do, so I can go on to step 2. Step 2 says to combine like terms on the same side. Now, in all honesty, this step, you don't have to do it. However, it makes things a little easier. It saves a little work down the road. So I'm going to start by looking at each side. Now, the left side, there's nothing to combine here. I've got 10 and minus 5x. This has a variable, that does not. They're not like terms. So I'm just going to write 10 minus 5x. But on this side, I do have some like terms. 6x, well, there are no other x's, so I'm not going to combine it. But I do see that I have a negative 9 and a negative 3. So I can combine those. Negative 9 minus 3 gives me negative 12. So everything is combined. So that's the end of step 2. Next, I'm going to move variables to the same side. Now this is a matter of preference, at least picking which variable to move. I personally prefer to avoid negative coefficients if at all possible. So to do that, I'm going to add 5x to both sides. Now if you wanted, you could subtract 6x from both sides. It would still work, it would give you the same answer, but you would have a negative coefficient. So I'm going to avoid that. Now negative 5 plus 5 gives us 0, that cancels out. So I have 10 equals 6 plus 5 is 11x minus 12. And that's the end of step 3. I've moved all my variables to the same side, so I'm good to go. Step 4 says to undo addition or subtraction. Now here's what this means. This means if I have a variable, or a variable with a coefficient, that means I'm going to move this component. Since I have a minus 12 here, I'm going to move it by adding 12. Because negative 12 plus 12 is 0. That cancels out. So 10 plus 12 is 22. Equals, that's canceled, so I'm left with 11x. So that's what I mean by undo addition or subtraction. Now there's only one step left on our foldable, and that is to undo multiplication or division. This one is pretty straightforward. Since I have an 11x here, this is 11 times x. So I'm going to undo that by dividing by 11. Now here's why this works. When I do 11 divided by 11, I get 1x. Now this 1 isn't necessary to write. Like I said before, we have an understood 1. So I can just write it as x equals 2. And plus, if I wanted to divide by 1, it would never change. So we've used the foldable to solve it. We followed all 5 steps, and we got an answer of 2. But we want to make sure we're right. Now the nice thing about solving these types of equations is you can always know if you're right or wrong. Here's how. I'm going to check my work. So here's how that works. What you're going to do is you're going to take the original equation. And wherever there is an x, I'm going to replace that with a 2. So I'm going to put a 2 there. I'm going to put a 2 here. So I get 5 times 2 minus 2 equals 3 times 2 times 2 minus 3 minus 3. Well, following order of operations, I can simplify this. This would be 5 minus 0. This would be 3 times 4 minus 3 minus 3. Well, this side, 0 times 5 is 0. And on this side, it gives me 3 times 1 minus 3, which, again, works out to be 0. So since it works on the left side and the right side, 2 is the solution to this equation. I hope this was helpful on how to use a foldable to solve a multi-step equation in one variable. If you like it, please subscribe, and if you have any questions, feel free to shoot me an email.